What if the sun doesn't shine? Well, your solar panels will be totally useless. What if there is no wind? Well, then the wind turbines will be useless as well. What if there is no water to power hydroelectric power plants? Well, there won't be any electricity. That is exactly the reason why so many countries are investing in new renewable energy sources. Right now, the most obvious thing to do would be the introduction of large-scale batteries which can store and balance energy demands once the grid becomes greener. But there's one huge problem, and that has to do with the fact that most of the batteries today are made of lithium. They're expensive, come with a huge carbon footprint, and they degrade over time. So what is the solution? Finnish researchers have finally given us the world's very first fully working sand battery which can store green power for months at a time. Yes, for months. So keep watching till the end of the video to find out a lot more about how sand batteries could solve our energy problems. The world is already moving towards a greener future, and as a result, governments are encouraging renewable sources of energy like solar and wind. But even today, solar panels and wind turbines along with hydroelectric power plants are the only renewable sources of energy that are commonly used. There is a major problem with all these energy sources, and that is intermittency. As a result, the world is waiting for a new renewable source of energy and energy storage solution that is capable of declaring war against one of the biggest challenges that green energies have to face, that is to provide energy all year round. A steady electricity supply from renewable energy sources is not practical because of changing seasons and variable weather conditions. The answer to all that problem lies in a Vaajajankoski power plant about 270 kilometers or 168 miles northwest of Finland's capital, Helsinki, using something remarkably simple, abundant, and cheap, which is, well, you guessed it, sand. A team of young Finnish engineers have completed their first commercial installation of a battery made from sand, which they think will solve the energy storage problem in an extremely low-cost and low-impact way. These researchers are also of the opinion that this battery could solve the problem of year-round supply, which has always been an issue with green energy sources. But why Finland out of all countries? Well, Finland is a country that receives most of its oil supplies from Russia, so the Ukraine war has negatively impacted the country's oil supplies, because of which Finland was forced to rely on green power. So what exactly is the sand battery? Well, it's as straightforward as it sounds. It is a high-temperature thermal energy storage solution which uses sand or sand-like materials as a storage medium. In simple terms, it just stores energy in sand as heat. The Vaajajankoski power plant is already home to the world's first commercial-scale sand battery. It's fully enclosed in a 7-meter or 23 feet high steel container, and the battery consists of 100 tons of low-grade builder's sand, 2 district heating pipes, and a fan. The sand becomes a battery after it is heated up to 600 degrees Celsius using the energy generated by wind turbines and solar panels in Finland. There are several concerns over the source of heat and light, especially in countries that experience long and cold winters. So in those countries, especially Finland, this new piece of technology promises huge potential to ease some of their worries. As of now, these sand batteries are only used to store energy as heat. These batteries are made using low-green sand, and the device is charged up with heat made from cheap electricity like solar or wind. The sand is stored at 600 degrees Celsius, which can then warm houses in winter, especially during a time when energy is extremely expensive. So how does this work? The renewable energy powers a resistance heater, which then heats up the air inside the sand. Hot air is circulated inside the battery by a fan around the sand through heat exchange pipes. This way, hot air is generated, which is then circulated in sand by means of heat exchanger. The thick insulation that surrounds the sand will keep the temperature inside the battery at about 600 degrees Celsius or about 1112 Fahrenheit even when it is freezing cold outside. These batteries can store about 8 megawatts of thermal energy. When the energy demand rises, the battery discharges about 200 kilowatt of power through several heat exchange pipes, which is enough to provide heat and hot water to 100 homes in a public swimming pool in Kankaanpää. These sand batteries can also be charged overnight when the electricity prices are lower. Clever move, right? The surprises don't end there. These batteries have low maintenance because they use cheap, low-quality sand that's rejected by builders instead of using high-quality river sand, which is used in the field of construction, where there's already a global shortage. The maintenance costs are also on the lower side because there is no wear and tear involved with the heat exchange pipes. A fan is the only moving component which can be replaced easily if necessary. But why sand out of all the solid materials that are available? Well, sand is already a very effective medium for retaining heat over a long period of time while also storing power for months at a time. Sand also has a very long lifetime, which means it can be used to heat up and cool off multiple times. It will get denser after a while, so it needs less space. That is when you could add more sand. The problem with lithium-ion batteries even today is that they continuously degrade even when they're not in use. years. But such a chemical reaction does not happen in sand batteries, so these batteries are totally immune to a similar process of aging. Lithium batteries are also not suitable for large-scale energy storage applications, and they are also flammable. There are environmental concerns too with lithium-ion batteries, as they have much bigger environmental impact than sand. For every ton of refined lithium produced, an equivalent of about 3 and 9 tons of CO2 is emitted, depending on how it is extracted. This does not mean that sand batteries don't come with any challenges. The technology is still at its infancy. The sand battery might need a major breakthrough in technology to make a really big difference. Only then these batteries will generate significant amounts of electricity. In its current state, these batteries will store about 5 to 10 times less energy than traditional chemical batteries. But it is still a far more cost-effective solution because these batteries are at least 8 to 10 times cheaper than a lithium battery, which stores the same amount of energy. Sand batteries are also extremely good for heating houses in countries with cold climates, but efficiency would drop when it is used to return power to the electricity grid. So in order to make it more practical, the team needs to build a way of converting the battery's heat back to electricity with at least 75 to 80% efficiency. And if that happens, that would change everything. The current technology of converting heat back into electricity has an efficiency of just 30%, which is an ideal if these batteries need to go mainstream. The next step in scaling up the battery for electricity generation is by adding a turbine to convert heat back to the grid as electricity. Sand is a very effective medium for storing heat and loses very little over time. But how much time? Well, developers already promised that the device could keep sand at 500 degrees Celsius for several months. So when the energy prices are higher, the battery will discharge the hot air, which will then warm the water for the district heating system, which is then pumped around homes and offices, even your local swimming pool that you visit frequently. Materials like sand can be heated to temperatures well above the boiling point of water. So sand-based heat storages can store several times the amount of energy that can be stored in a water tank of similar size. This is all thanks to the large temperature range allowed by sand. On top of that, it also saves a lot of space, and it's extremely versatile to be used in so many industrial applications. Now you might be thinking how exactly the heat storage is insulated. Well, the heat storage is made up of steel, and it's usually insulated with standard heat-resistant insulating materials. The insulation is provided around the heat storage between the outer steel layer and the inner one. Energy can only be stored in the form of heat, and this heat can be converted back to electricity using turbines like the organic Rankine turbine. But this requires additional investments to the turbine technology, and conversion to electricity has inherent losses which will just complicate things if you're looking at the economic side of things. The idea of heating sand to store energy is not new, but today we have the capability to commercialize it and also introduce it on a larger scale. This makes a lot of sense because the world is shifting towards renewable energy. But the intermittent nature of these energy sources creates a lot of challenges to the energy networks. The sand batteries might be one among the best solutions after lithium-ion batteries for energy storage. If you think about it, it's a very simple idea. But perhaps this is the very first time such a concept was executed on a larger scale with a working commercial system that's performing extremely well.